Tutorials, and in this video I'll be looking at, so this is the first video under trigonometry. So basically I just want to do an intro to this. I'll be looking at the reduction formula in this particular video, as well as special angles. So just write our topic. Let's just get that. So you're going to be talking about trigonometry. Okay, so now to start with, I just want to highlight the main trig functions which we're interested in. So basically we have, let's say, sine x, we have cosine of x, we have tan of x. There are quite more which you can actually encounter, but these are basically the main ones, and you can actually form the other ones using these three. And these come in quite a few forms, and those forms are usually confusing if you don't reduce them or if you don't simplify them. So we have something called the reduction formula, which is aimed at simplifying your analysis of trig functions or trig equations. And so our aim is to simplify, basically. So now you might have seen this diagram in previous grades or anywhere else, and it's actually helpful for you to remember where each of your trig functions are positive, right? So you're actually going to use this cost diagram. I call it a cost diagram. You can call it whatever you like or whatever is easier for you. And you have 0 degrees over here, or 360 degrees. You have 90 degrees over there, and you have 180 degrees over there, 270 degrees down here. Now, on this diagram, or on this Cartesian plane, we basically have the anti-clockwise direction as increasing or positive, right? So when we talk about, let's say, positive 45, it'd actually be moving from this 0 line and measuring 45 in that direction. So positive 45 would maybe lie somewhere there. So the positive side is the anti-clockwise side, and the negative side is the clockwise side. So that is something to note, and that is something to remember. Now this diagram, let me just explain this diagram. Here you have your cosine, so it's cast going like that, starting in the 4th quadrant. So cast is how you'd read it to remember how to draw it, starting from this quadrant, which is the 4th quadrant. So basically here you have cosine as positive. Here you have all the functions as positive. Here you have your sine as positive. Here you have your tan as positive. And if your argument for the angle, or if the angle which is provided next to your function falls in one of these quadrants, you have to check if that function is positive in that quadrant. And if it's not, you basically assign a negative sign with the symbol which is inside the bracket. And this is what that means. So we have 4 quadrants. We don't really have to worry about this one because all of them are basically positive in that quadrant. So that quadrant would be denoted by, let's say, a symbol theta for the angle, and that would be an acute angle, and that would fall basically in this department or in this quadrant, and all of them would be positive, whether it's sine, cos, or tan. So then we're going to look at the other quadrants. So if you look at the 2nd quadrant, which is over here, looking at the 2nd quadrant, to get there, we basically say 180. So we go 180 degrees to that point. Then we go an acute angle backwards, which is, let's say, theta. So negative theta. So 180 degrees subtract theta would lead us to this quadrant over here, right? And in that quadrant, only sine is positive. And therefore, if we had to do a summary of all of the quadrants, so starting with the second quadrant, which is denoted by 180 subtract theta, you therefore have your reduced formula or your reduction formula as sine theta, because it's actually positive. So this is positive sine theta. It's positive sine theta. Now, if you were to input something like cosine of 180 degrees subtract theta, which also occurs or which also falls in that quadrant over there, as you can see, we have s in this quadrant, which means only s, the sine function, is positive, and therefore we expect our cosine to be negative, and therefore we'll have negative cosine of theta as our reduction formula in the second quadrant, so negative cosine of theta. And finally, the same thing applies to tan, because in the second quadrant, denoted by 180 degrees subtract theta, we'll have a negative tan theta as our reduced formula. So what we are basically doing is using this diagram to represent each of the quadrants. You can see that the second quadrant can be represented by 180 degrees subtract theta, which means we go 180 degrees and get to this point and then go back by theta, and we found ourselves in that green quadrant which I just highlighted. And we can move on to something like the third quadrant. So let's do the third quadrant while we still have our okay, we can just draw it again down here, just so we have more space. So basically we have 90 degrees there, we have 0 degrees, and it says cast. I have 270 there. This is also 360. Then here we have 180 degrees. So now we're interested in the third quadrant. So looking at the third quadrant, it's over. So we count like this. This is 1, this is 2, this is 3, and this is 4. So we basically here, how can we get to the third quadrant? To basically go 180 degrees, but we're at this line right now. So what do we have to do to actually get into this quadrant? We basically add theta, which is an acute angle. So then for this quadrant, we have 180 degrees plus theta. And as you can see, we have t in that quadrant, which means only the tangent is positive in that quadrant. So that is what we expect. We expect tan of 180 degrees plus theta equals to positive tan theta. And we expect the other functions to be negative. So basically, you're going to have that negative sine theta. Then you're going to have cosine 180 degrees plus theta equals to negative cosine of theta. That is what we basically expect, because in that quadrant we have t, which means only t is positive. Moving on to the fourth quadrant, let's look at the fourth quadrant, which is over there. You basically have c in that quadrant, which means your cosine should be positive in that quadrant. And therefore we can say that cosine of whatever angle is equals to positive cosine. So we're going to have theta there. But what is the description of this quadrant in terms of angles? We're going to go 360 degrees in the positive direction. Then we're going to subtract theta to end up in this quadrant, which is the fourth quadrant. And therefore the description of that in terms of angles would be 360 subtract theta, which is equals to cosine of theta, the positive cosine of theta, because that is basically its quadrant, the fourth one. And everything else will basically be negative. So you have negative sine and you have negative tan. Right? Okay, so that is basically all I had to discuss with regards to reduction formulas. And before I move on to negative angles and the last part, which is special angles, I just want you to note the following, which are co-ratios. All right, and these co-ratios basically say that if you have the cosine of the following. So cosine of 90 degrees subtract theta, it basically becomes sine theta. These are just transformations which you should know, and they're gonna be quite helpful as you go along. So you must know this. You must know this. These are called co-ratios. Didn't discuss them because they are not particularly related to any of the quadrants. Just that you have to know how to convert from your cosine to sine and from your sine to cosine. So that is what your co-ratios help you with. We're now going to move on to talk about negative angles. So let's talk about negative angles. And as we talk about these negative angles, we're basically going to be using the same cast diagram. It's going to be quite helpful to us. And in the analysis of negative angles, we just basically have the same diagram, but we are moving in the opposite direction, or in the negative direction. Now, if you move from here, the starting point, towards that direction, that is a clockwise movement, and therefore moving from this point to that point would mean that you're actually moving negative 180 degrees, because the clockwise direction is the negative direction. So now you can actually associate all of these quadrants with a description of the quadrants, right? But in the negative direction, or in the negative fashion or sense. And the second quadrant, to get to that, you basically just say negative 180 degrees, and then you'd basically subtract theta to get into this quadrant, which is the second quadrant. So for the second quadrant, you basically have negative 180 degrees subtract theta. For the third quadrant, you'd basically have negative, which is over here. So this is the third quadrant. So if you move from that point to that point, you have negative 180, just so I pin that. So that's negative 180 if you go in the clockwise direction. Now, if you want to get to the third quadrant, you basically go in the clockwise direction and then come back in the anti-clockwise direction and actually add theta. So you basically have negative 180 degrees, which would get you to that point. Now that you're at that point, how do you actually get to this point? So to get there, you basically add theta. And that will bring you back into this quadrant over there. And since you have that, you basically just have that. And your fourth quadrant, you basically say, for the fourth quadrant, just subtract theta, which is an acute angle. So starting from here, this would be negative 90 degrees. So if you subtract an acute angle, you find yourself in this quadrant over here, right? And that is basically how you describe all of those quadrants using negative angles. And the analysis is still the same. In your second quadrant, you have your sine positive. So sine positive in your second quadrant doesn't change now that you have your negative angles. In your third quadrant, you still have tan as positive. That doesn't change. In your fourth quadrant, you still have your cosine as positive. That hasn't changed. So all of this holds, just that you are basically describing the same quadrants using negative angles. So that was basically all about negative angles, and we can now move on to special angles. Now I'm going to draw an interesting diagram which is going to be helpful to you. So let me draw it properly since it's going to be helpful. I'm just going to draw it properly so it's quite neat and so you can follow. Excuse me. Okay, so I'm going to try to draw a straight line. So straight line from there to there, it's going to do something like that. And that isn't straight again. So let's try that. Okay, that's much better. Then you're going to have a line there. This is not drawn to scale, please note. But I hope you understand what I'm trying to teach, what I'm trying to talk about. So from this point to that point you have, okay, let me remove that. From this point to that point you have 30 degrees. From this point to that point you have 45 degrees, and the angle here from that all the way downwards is 60 degrees. Okay, so that is the angle which you have for each of the lines. So here you have your 90 degrees, here you have your 0. So now special angles basically help you to compute the values of your sine, cosine, and tan in a much quicker way. So instead of using a calculator, you can just basically use this diagram to actually find the values of some of the most common angles. And here's what you do. So each point is defined by an x and y coordinate, and each of these x and y coordinates can actually be defined as r cosine theta and r sine theta. So the x is associated with r cosine theta, and the y is associated with r sine of theta, and the r is always equals to, so the magnitude of that, or the length of that is always equals to 2 in the case of special angles, right? So this is for special angles, and not if you have another diagram where you're actually told the length, like moving from a point, maybe you're told that the length from there to there is like 25, and you actually have to solve for the values of x and y. That is not the case here. Here I'm talking about special angles. So we are talking about special angles, right? So basically, always for special angles, your r magnitude is equals to 2. And now basically you have this relationship between x, y, and your r. You have x squared plus y squared equals to r squared, which is the Pythagoras theorem. You always have to explain that, Pythagoras theorem, something like that. You always have to give an explanation for that if you ever apply that in a test situation. But for special angles you don't have to, because it's inherent, it is assumed, but you can go ahead just to be safe. So then we said that the x is actually associated with r cosine theta and y is associated with r sine theta. And to find the values of your trig functions, which are cosine theta, sine of theta, and tan of theta, you basically come to this diagram and associate each angle or each point with x and y coordinates. So you start at the bottom, or at the top, just so it makes sense to you. Starting at the top, you're basically going to say 0, 1, 2, 3, 4 as your x coordinates. Then moving from where you left off, which would be the bottom, you're going to say 0, 1, 2, 3, and 4. Now everywhere, you're basically going to put a square root sign. So square root of 0, square root of 4, which is 2, square root of 1, which is 1, square root of 3, which is square root of 3, square root of 2, square root of 2, square root, and square root of 1 is basically 1. That's why I won't put it there. Then here you have square root of 4, which is 2. Then you have square root of 0, which is 0. So basically, you move from the top, starting at the x, 0, 1, 2, 3, 4, going down. Then you move from the y, so the y originates at 0 from the start point. Then you go 0, 1, 2, 3, 4. Then you put a square root sign on everything. And that should give you your x and your y values depending on the angle that you basically have. So cosine of theta is equals to your x coordinate divided by r, and your sine of theta is equals to your y coordinate divided by r. And your tan theta is equals to your y coordinate divided by your x coordinate. So now, if we have this diagram and we're asked to find, for example, cosine of 60 degrees, sine of 60 degrees, and tan of 60 degrees, we'd come to the diagram and follow this, which is, for cosine, it's x divided by r, which means that the answer for cosine of 60 degrees would be the x value divided by r, which we said that r is equals to 2. So the x value is 1 and r is 2. So that would mean that our cosine of 60 degrees is equals to a half. And we got that without using a calculator, as you can see, which is quite simple. And that is basically the reason that we have this diagram. And your sine of 60, if you come to the y, so your sine is y divided by r. So your y value at 60 is square root of 3. So you're going to have square root of 3 divided by 2. And that is the value of sine 60. You can check that with your calculator. And we come to tan of 60 degrees, which is basically y divided by x. So y divided by x is the ratio for that. So if you have that, you're basically going to take your y value and divide it by your x value. So the answer to that is square root of 3 divided by 1, which is square root of 3. So we have all of the values of these common angles: cosine of 60, sine of 60, and tan of 60. But we found all of the values without using a calculator. And that is basically the reason behind the diagram, as I previously said. And you must know this diagram because it's going to simplify your analysis of a lot of things. Excuse me. It's going to simplify your analysis of a lot of things. And from this diagram, when you reduce any angle or any trig function which happens to have the common angles 30, 45, and 60, you can just quickly compute the value of that, and without even looking much at your calculator. Or if a question actually says you shouldn't use a calculator to simplify certain things, then you basically have to show all your steps. And your steps would actually include you turning this value into that. And to do that, you're basically going to use this diagram which I drew. So that was just an introduction into trigonometry. We looked at the reduction formula, negative angles, co-ratios, and special angles. And of course, I'll do examples at the end of this series, and I will see you guys in the next video. That is all for this video. If you haven't subscribed, please subscribe. And if you like this video, please give it a thumbs up. And that is all from me. And please, 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 if you don't understand anything, just leave a comment in the comment box or in the comment section, and I'll be glad to help you or to answer any of your questions. And I've been talking for quite a long time now. So that is all from me in this video. I'll see you next time.